Hello everyone, this is Kritika Ramasubramanian. I am here to present a paper on a framework for migrating relational datasets to NoSQL by Leonardo Rocha, Fernando Valle, Elder Cirallo, Dialton Barbosa and Fernando Maura. As an abstract of the paper, we know that migration from one database management system to another is a challenge for programmers as the change in the application code for the new DBMS is vast. So, a framework is presented to make this migration from relational to NoSQL conveniently possible. Therefore, the main contributions of the paper are to present a framework with two parts. One is the migrating module and another is the mapping module. Migrating module consists of a set of methods enabling seamless migration, and the mapping module consists of a persistent layer to process database requests. We also have some experiments to prove NoSQL layer can handle large volume of data. In introduction, in the modern era, the software applications are designed to process large volume of data for small group users and large organizations. Till now, the relational database management system was able to succeed in fulfilling the requirements and succeed through its simple and efficient features. However, RDBMS is not much efficient to handle unstructured data, and to fulfill this need, NoSQL, not only SQL, a newer version of DBMS has been proposed. But these are challenges like migration of data, data redundancy, and cost for adaptation in the new model that causes many large-scale organizations to be still based on RDBMS. To face these challenges, a new layer known as the NoSQL layer is presented to perform data and model migration by offering an abstract layer to access data transparently, thereby maintaining the semantics of the original database. Each SQL operation is converted in a NoSQL model, processed, and the result is changed back to the SQL format. There are two types of evaluation. One is the qualitative evaluation, another is the quantitative evaluation. In the qualitative evaluation, entire migration process and the execution of operations are done to prove the results to be identical. In the quantitative evaluation, it performs experiments to evaluate the overhead by NoSQL layer to prove its efficiency and performance. Next are the characteristics of RDBMS and NoSQL. In RDBMS, tables are defined and stored by rigid schema, while in NoSQL it is not needed. Key value in React, Redis and Project Voldemort, document oriented in MongoDB, CouchDB and SimpleDB systems, and column oriented in Google Bigtable, Cassandra systems shows the distinct characteristics in NoSQL models. For certain type of data, RDBMS shows better results, while for the others, NoSQL is better. So the data requested is analysis first, and to find which method can yield correct results. Here, all data are stored in NoSQL database by storing structured data in the relational database and unstructured data in the form of CSV, XML, etc. The interceptor controller mediator protocol is created and used in site tracking in the information flow to ensure the application is not changed when the data source changes. Next is the NoSQL layer. To keep the application unchanged with data stored in the relational database, NoSQL layer and abstraction layer is used. NoSQL layer has two modules. One is the data migration module, another is the data mapping module. Data migration module identifies the elements in the original database, creating equivalent structure in the NoSQL and migrate the data. The data mapping module contains a persistent layer to monitor the SQL transactions, translate and redirect to the NoSQL model. Then, the result of each operation is treated and transformed to the standard expected by the SQL application. Next is the data migration module. First, the analysis of the relational database is done to find out which metadata is required at the conversion process. Identify all the elements of the database, thereby helping in handling the relational database implemented using MySQL DBMS. Given is a figure of data migration module working diagram with relational database and NoSQL database on the either sides with the metadata, and there are like three modules which are like metadata retrieving module, NoSQL creation and table migration module. MySQL, like other DBMS, contains data dictionary which has the information required by the data migration module, but each DBMS varies accordingly. This implementation uses the Java database metadata with several classes and methods that facilitate the recovery of metadata in order to make NoSQL layer extensible to all types of DBMS. This API can be instantiated using their respective drivers, like how MySQL uses the MySQL connector. Given us a description of the main methods of the database metadata API, in which the method and the description are as follows. The method are get tables. The description of the method will return all table contained in the database. Get columns method retrieves the names of the attributes of the given table defined by the parameter and their characteristics, and furthermore, this method also allows the identification of the primary keys. Get index info method. This method retrieves all indexes created on the relational database. Get metadata method. Other information of the relational database are obtained by this method, such as integrity constraints and data types. Currently, NoSQL layer supports MongoDB, a document-oriented NoSQL DBMS that stores data as documents, allowing the representation of complex data structures. After identification, create a new scheme suitable for NoSQL database. This new scheme creates in MongoDB a table for which existing in the relational database. The records of each tables are retrieved and mapped as documents, where each attributes of the tables are represented by fields in these documents. The relationships among the tables are represented by document references to facilitate the mapping module in transactions with the table joins. For each identified index, a function ensureIndex is used to set the names of the indexes in the collections. NoSQL layer creates a specific collection in the MongoDB known as the metadata to store all the information collected, such as table names, names and types of attributes, and integrity constraints. This collection is to check whether the integrity constraints are being met and the types of data are used. Metadata is used for mapping operations to retrieve information of the attributes in the SQL operations that restores the response forwarded to the application. Finally, the data migration is done by mapping the request on each table of the relational database stored in the MySQL onto data insertions in the corresponding collections of the MongoDB database. Next is the data mapping module. The main aim of this module is to allow a seamless database migrations to prevent change in the application code before the changing the data model used. So, queries are created in the relational model, but the data is fetched in the NoSQL database, thereby providing performance and scalability features of the system. Given as a figure, data mapping module working diagram, which has the application and the mediator mapping with the two databases, NoSQL database and the relational database. First, the module intercepts the application issued queries to redirect it to a suitable NoSQL DBMS. For this, a submodule known as a mediator is needed, which is created by the MySQL proxy, which uses the LUA language for data manipulation. The MySQL proxy has predefined functionalities and it can be changed by the LUA to intercept queries and forward it to the query conversion submodule. Here, using LUA SOAP library is used to communicate between the mediator and the request conversion submodule. It uses SOAP, Simple Object Access Protocol, and XML files containing all the information related to the operations. Next, the conversion submodule known as Convert was developed as a web service in the Java language. It receives all the requests from the mediator and converts into queries. It also waits for the new request in the form of XML file. Given is a sample XML file in which the first attribute of XMLNS represents the class of the attribute and second attribute represents the method of execution. The required parameters query and the query types are given in this XML file, which represents the request intercepted and its type respectively. In the given sample XML file, the query shows the select operation and the query type shows the type of the operation, which is select. Convert evaluates the query type parameter to find the next procedure to be executed. For each operation, the method performs a given operation in NoSQL and returns the result to the application. All the methods performs the following three steps. First step is the information extraction about query. It evaluates the query parameters to extract additional information on SQL operations. It is implemented by the Java library JSQL parser. Each method defined differs according to the information it requires. Next step is the generation and implementation of equivalent operation in NoSQL. It translates the SQL operations onto its equivalent NoSQL ones. The metadata collections with the relationship of the database is used. Operation is executed in MongoDB with the results are obtained in the next step. The next step is the mapping return results. The results from the MongoDB are sent to the application through the mediator. The results header with the identification and the elements related to the result is built. Then each record is mapped, and based on this information an XML is built and sent by the convert to the mediator. Given is an XML file which has been built by the converter and sent to the mediator. In this XML file you can find in the return tag with a header which has identifications and elements related to the result. NoSQL layer also supports SQL operations such as delete, thereby removing the items according to the select operation. First, NoSQL layer triggers the method related to the most external operating, and when the nested transaction is identified, the method of that operation is triggered and the information for external operation is returned. For the delete operations, the corresponding method identifies the select operation, invokes the method for it and returns the result to the delete operation. Each nested operation of the corresponding method is invoked, and it also supports the recursive calls with the limitation subject to the availability of the hardware. Finally, we find that XML sent by the convert is transformed to the MySQL format by the mediator using the MySQL proxy. Next is the evaluation. NoSQL layer presents two types of evaluation. One is the quantitative analysis and the qualitative analysis. First is the quantitative evaluation, which is the proof of concept to show NoSQL execution in practice, and the quantitative evaluation, which verifies that use of NoSQL proves the system performance. For this we need an experimental setup which has two relational database is used. First relational database is the database from DB3 schools, a web developer information website with unique characteristics such as integrity constraints, relationships or types of data. Second is a database model for an application that collects and stores user posts from Twitter. It has a high volume of data so that it can be useful for quantitative evaluation. Given as a figure of the database models used in the evaluation. First is the DB3 schools database model, which has the tables like suppliers, products, categories, customers, shippers, orders, employees and order details. Second is the Twitter, which has both tweeters and the user tables, in which the tweets table contains tweets details and the user tables contains the user details. Both the database are implemented in MySQL, and a Java application was created to perform SQL operations, and this type of scenario is known as the MySQL scenario. For each application, another version is created for the migration of the entire MySQL database to the MongoDB through NoSQL layer, and this is known as the NoSQL layer scenario. Here, NoSQL layer also captures and maps the operations for the corresponding applications. Though several SQL operations are used, certain operations that uses the operators such as set operators, maps functions, order by, different joins are selected, and they are purposefully tested for the evaluation. Next is the SQL operations performed in this evaluation. This table consists of an identifier, dataset and an operation. The identifier has the type of operations like select, delete, insert, update, and the datasets contains the different types of database models like Twitter app and DB3 apps, and the operation contains the specific operations of the given select, delete, insert, update queries. And for example, in a select operation, for select one identifier, the dataset taken as a Twitter app, and the operation is a select created user ID from collections where user ID in the given values. Next is the qualitative evaluation. This evaluation is done to find whether the NoSQL layer affects the functionality of the applications for SQL operations. The evaluation has varying amount of data selected from the operations. For the qualitative evaluation, there are two scenarios, which are the query operations and the operations that change the database state. First scenario is the query operations. The applications that identifies the files are executed and the results are stored in the another file. The results of each operations are generally stored in a plain text file. Therefore, with the result, we find that no anomaly has been occurred for the results for the given query operations, thereby proving the working performance of the NoSQL layer. Second is the scenario 2, operations that changes the database state. Each execution of the operation changes the database state. Thereby, we dump tables and the results in the text files are stored in the order of their operation. These results are then compared to show that they does not differ from each other. This proves the quality of the functionality and working performance of the NoSQL layer. Next is the quantitative evaluation. This evaluation is to prove that NoSQL layer has advantageous performance despite the overhead of defining a layer between the application and the NoSQL database. Here, varying amount of data is used. So for each query operations, the records in the database are changed by performing insert, update, delete and operations before each query. Here, the execution time is calculated for the instance of the application to the instance of the result. It is based on both MySQL and NoSQL scenarios. The operations are done 10 times and with that average, it is executed for the final time. The specifications for the systems used are Intel Core i3 2.53 GHz, 4 GB RAM, 500 GB hard processor system using operating system Ubuntu 4.13 64-bit. The results for the select operations and the execution time for different operations like select, delete, insert, update are plotted as a graph with the graph along the y-axis. Here the graph is plotted for the execution time for each select operations like select 1, select 2, select 3, select 4, and for delete operations delete 1, and insert operation insert 1, update operation update 1. The results from these graphs plotted report that MySQL has an increase in response time for increase in volume of data. For large volume of data, excess amount of CPU is used. So, MySQL uses a new processing unit which causes large response time due to synchronization issues. On analyzing the plots for the change in the database state, NoSQL layer is more efficient with a lesser runtime compared to the MySQL. This efficient performance of NoSQL layer is due to the integrity constraints of the change in the database state. The NoSQL layer supports only the primary key constraint through metadata. Therefore, with these results, we conclude the experiments that NoSQL is much more efficient compared to the MySQL. On conclusion, we conclude that this paper presents a NoSQL layer. We have seen a NoSQL layer, a framework for migration between the RDBMS and a NoSQL database. It also has a persistent layer that allows applications to access data in the NoSQL without performing the original queries modification. Then we have done two types of evaluation. One is the qualitative evaluation and second is the quantitative evaluation. Qualitative evaluation was performed to compare the results of operations in SQL, MySQL, MongoDB, and it proved the efficient performance of the NoSQL layer. Quantitative evaluation compares the runtime of the varying amount of data, and the NoSQL was found from the results that it was found to be more efficient despite the overhead by the persistent layer. Therefore, we all conclude that NoSQL layer is suitable for handling large volume of data. And regarding the future enhancements, NoSQL layer can be extended to other technologies and management systems, and due to its efficiency, I think NoSQL can be extended more to give more efficient features, and its features can be much more advanced. Thank you.